Okay, welcome everybody to Brookings. Good afternoon. Okay, I go to a Black Baptist church, and when the preacher says good afternoon, you guys say it a little louder. Good afternoon, everybody. Good afternoon. Thank you so much for fancying me. Everybody just went, good afternoon. I know there are more people for our webcast audience than the 5 or 6 that sounded that soft. I'm Nicole Turner-Lee. I'm a fellow in the Center for Technology Innovation here at Brookings. I'm happy to host my first event of the year with these 2 great people who are sitting next to me, both of which have an individual story about me that they will not tell for any money. Today's topic actually continues a series that we actually launched last year at Brookings on artificial intelligence. My colleague and boss, Darryl West, and I have put together a series around AI governance as well as bias. And Brookings overall has also dealt with the issue of national security. For those of you who have not yet seen it, on our website under the tab of AI are a series of papers in the area of governance and bias, and we actually just encourage all of you to go to the website because there's just great content, including the content of a recently released paper by the 2 panelists here, which we'll talk about today. So again, under the AI section on the Brookings website, you'll find 2 streams of paper on governance and bias that I encourage you to actually not only look at today, but to continue to track as we actually put more content from reputable scholars across the country and the world on that site. I'd also like to remind you, because we obviously have an audience that is in person as well as webcast, that you use the hashtag AI bias to have the conversation while the panel is going on and to continue it when it is over. These conversations are valuable, but if the only people who are actually talking about are us, right, Tom, then it's really not doing much. So we ask that you continue the conversation. I'm really excited about this conversation today on bias, and for a lot of reasons, but the first one, most importantly, being that I'm a sociologist sitting with 2 computer scientists. Doesn't happen that often. And so I'm excited about the fact that my 2 friends have decided to join us today to talk about a book that they recently put out called The Ethical Algorithm. So sitting right next to me is Michael Kearns, who's a professor and National Center Chair for Computer and Information Science at the University of Pennsylvania. And next to him is Aaron Roth, who is a 1940 bicentennial Associate Professor of Computer and Information Science at the University of Pennsylvania as well. Let's give them a round of applause. And I will shamelessly say it one more time that they put out a book called The Ethical Algorithm that, again, as I promote my book and others here, we'd want people to say it repeatedly, that you should pick up, that will go deeper into the content that we're going to discuss in this next hour. So my plan is to ask you guys questions, and then, again, we're webcasting, so there are people who are watching us online, and we have people here in the audience. At a certain point in the discussion, we'll open it up for Q&A, and then move forward from there. So I'm just going to jump right into it because I want to make sure we save enough time for Q&A. Let's start with what is the ethical algorithm? So give me something to work with there. I did read, parts of the book, didn't get through everything. Also read a lot of the commentary in the book, but I would love for you to unpack what do you mean when you say the ethical algorithm?
Yeah, so our book is really meant to be a popular science book. Many of you are aware about kind of algorithms gone wild, situations in which algorithms inflict violations of people's privacy or make discriminatory decisions in lending and other domains. And we are basically representatives of a sub-community of the AI machine learning research community that basically is trying to design better algorithms in the first place. So, to say it very briefly, we're part of a community of people that try to pose precise definitions, precise mathematical definitions for concepts like fairness or privacy. Then once one has committed to such a definition or definitions, to walk down the road of actually implementing those definitions in algorithms, like literally putting them in your Python code, for instance. And then exploring what the consequences of that are. Both from a quantitative kind of mathematical perspective, like trade-offs between things like fairness and accuracy, and also more generally of the societal consequences as well.
Mm-hmm. Aaron, you want to jump in?
Yeah, so I think that the sort of starting observation for a lot of the work that we do and that we talk about in the book is that many of the examples of algorithmic misbehavior, so examples of discrimination, examples of privacy violations that many of you in the audience will be familiar with because they've been featured in the popular media so much in the last few years, are not the result of some, malicious software engineer hiding behind a curtain who is intentionally encoding, for example, racism or sexism into the algorithm. In some sense, that would be easier to deal with. We have sort of regulatory understanding for how to deal with malfeasance. The problem is worse than that, which is that these are the unintentional side effects of the standard machine learning pipeline, where you specify some reasonable sounding objective function, some proxy usually for accuracy or profit, and then you use an automated technique, a machine learning algorithm, to search over a vast space of different models and algorithms to optimize for that narrow objective. And it's hard to predict what you're going to get out of this pipeline, except that you're likely going to get something that's very good as measured according to your narrow objective. But what we've been seeing is that there are often unanticipated side effects that take the form of things we think of as unfair or violations of privacy. And so what you need to do to avoid this is first think very hard about what it is you mean when you say that you don't want unfairness. It's not enough to talk about it in English. You have to think in a mathematically precise way if you're going to embed this as a constraint into an algorithm, which is a mathematical object, and then you've got to solve the algorithm design task.
So I want to go into that because I'm a sociologist. I'm not a scientist. When you talk about these precise definitions of fairness and accuracy and ethics, even so, what do you mean by that, right? Because part of the challenge that we have when we're actually looking at algorithmic fairness is there are many different definitions of what that means. So I'd love to hear from you all, like, what is the preciseness of that definition that you're referring to?
Yeah, so maybe one comment worth making early is that when we talk about precision, we don't necessarily mean that there's a single precise definition.
Okay.
There might be more than one precise definition. So to ground this a little bit, often definitions of fairness start with, first of all, a group that you want to protect, like a racial minority, gender, et cetera. And then what you consider constitutes harm to that group in a particular application. So let's take consumer lending, for instance. So first of all, these days, things like consumer lending decisions are largely becoming automated and algorithmic, and I think everybody knows that. And so in the context of algorithmic lending decisions, I might decide like, well, I want to protect a racial minority, and the harm I'm trying to protect them from is false rejection for a loan. So I want to prevent the event that somebody who is creditworthy and would repay a loan, if I gave it to them, is actually denied a loan. And because when we talk about algorithmic decision making these days, we usually mean more specifically predictive models trained using AI and machine learning methods. So it's not that like a human programmer sat down and wrote Python code to decide who gets a loan and who doesn't. They instead wrote the code that searches based on historical data for the model that then is the actual algorithm that makes the decisions. So because of this, because it's statistical, you're going to make mistakes, right? And so, in lending, there's kind of two types of mistakes you can make, right? You can give loans to people who default, or you can deny loans to people that would pay them back. And so maybe we decide that, well, what constitutes harm here is being falsely denied. And so one specific definition of fairness that you could ask for is you could say, look, I don't want to just find the predictive model that makes the overall error as small as possible. I want to find a model that makes the overall error as small as possible, subject to the additional condition that the false rejection rate on the minority group and the majority are the same, okay? Now, let me just use that to go one step further. I could ask that they literally be the same. So whatever the false rejection rate on the minority group is, it has to be identical to the overall rate. But I can relax that also. I could say like, well, they don't have to be identical, but they have to be within 1%, or I could say within 5% or 25%. And importantly, this gives us a knob or a parameter, as we would call it in machine learning, that lets us basically say how much fairness we want or how much unfairness we're willing to tolerate. And why would I want to do that? Why wouldn't I want to always say like, well, no, make these error rates identical? Well, when I do that, that's going to come at the cost of overall accuracy, right? Because it's just a stronger constraint. And so this knob lets us quantitatively explore things like the trade-off in a particular data set that we face between accuracy, which in general we want, but also the amount of fairness that we're demanding.
Right. Aaron, you want to chime in? Because I got some follow-up questions.
Yeah, maybe just briefly. So along the lines that, we're not proposing that there's one universal definition of fairness. Rather, there's a thought process that you go through when you think about what you might mean in a particular circumstance. The kind of definition that Michael's talking about is one of many that follow the following form. You think about in your context, what is the action that sort of causes harm? What's the kind of mistake you can make in your predictive technology that causes harm? And then you ask that the harms that are caused by your algorithm, and your algorithm is inevitably going to cause some harms, because again, it's not perfect, shouldn't be disproportionately borne by one population. Somehow, the premise here is that if these harms are sort of if these harmful mistakes are sort of made at random, spread across the population, maybe that's okay, but the thing that we don't like and the thing that is often flagged as objectionable in the popular media is when we find that these sort of mistakes of the harmful variety are disproportionately concentrated in one group. And if you can identify what, in your context, in your problem, what are the harmful mistakes, you can try to design your algorithm so that those harmful mistakes are not disproportionately concentrated in one group.
So I want to kind of unpack that a little bit, right? So I've sat on panels as a sociologist where scientists have suggested that 1% in accuracy means that the automated decision has done a better job than if, something was, physically, like in mortgage approvals. So there was an article that came out recently that said automated decisions do a better job in approving loans, primarily because you take out the potential discrimination by the lender if they see the person's race, gender, etc. The challenge I'm having with some of the comments, and I want you to help me with this because I think the trade-offs where people like myself get nervous, that though the accuracy is improved by 1%, it doesn't necessarily stop the fact that in a criminal justice algorithm, you're still over-incarcerating 1% of the African-American population because they automatically start out flawed in that database. Or you're still rejecting 1% of people of color who are denied loans because they already start out flawed before they even enter the system. So speak to me a little bit about those trade-offs, right? And there's been some conversation in some panels that I've spoken about where some people say, well, sometimes you got to take a trade-off because the reduction in the human error turns out to be better because more people who may be denied loans, actually, goes away or there's a decrease in that number. So help me unpack that a little bit in terms of the conversation that I have at a dinner table oftentimes with scientists around accuracy and trade-offs.
Okay, let me first try to unpack what you said, which had a lot in it. So first of all, I think at the beginning of your question, you were sort of alluding to the feeling that some people have that because algorithms are involved in decision making, that somehow things like racial, gender, or other biases are reduced or eradicated. And I think this is, now demonstrably false, right? I mean, I'm sure there's a new news article somewhere today about an instance of demonstrable racial or gender bias in some predictive model. Now, so we tend to think of racism, for instance, as a human trait, and of course, before computers were used for things like lending decisions, there were such a thing as racist loan officers. But just because we replace them with computer programs doesn't mean that we eradicate these problems. And there's at least two important ways that these biases can creep into algorithmic decision making. One, of course, is just if the data that you feed to your predictive model in the first place is biased. So, for instance, if police officers are racist and selectively stop and frisk a minority group more often than the majority, they're just likely to find more contraband, for instance, than in that particular group. And if you just naively feed data like that to a machine learning process, not surprisingly, it's going to learn, okay, this minority group seems to be carrying contraband more than the background population. Even if you eradicate that kind of bias, that doesn't mean that you won't end up with a biased model, even if the data is kind of unbiased, whatever that might mean. Again, because machine learning is essentially an optimization process. And if I ask a machine learning algorithm to find the predictive model with the lowest error, full stop, and it happens to be that there's a model that has infinitesimally smaller error at the expense of huge racial disparities, it's going to go for it, right? Because I phrased it as this quantitative optimization problem. I didn't ask for any notion of fairness, so I'm not going to magically get it for free.
Right.
I think you were also kind of alluding to things that I think we think are not well addressed in the scientific literature right now, which have to do with kind of counterfactuals and kind of things I think that start to bleed into affirmative action issues, which is like, okay, maybe it really is the case that in this, that in some particular community that's lower income, small business loans are a higher risk than in some wealthier neighborhood. And so there's actually a legitimate argument to not give loans in that impoverished neighborhood as much as in the wealthier neighborhood. But then you can sort of say well, but maybe maybe this neighborhood is impoverished in the first place because of your history of not giving small business loans to this community. And if you did that for a while, then you would raise their fortunes. And in fact, now everybody could win because now here's a whole new community of people that are good lending risks for the lender. And this kind of sort of accounting for feedback loops where some algorithm or process or human organization is making decisions over time, and their decisions in turn are affecting kind of the nature of the population that they're making decisions about, is something that you could in principle incorporate into machine learning methods, but very little of it's been done so far.
Yeah. Did you want to respond?
Yeah. So maybe to the point of trade-offs.
Yeah.
Maybe people like us talk about trade-offs sometimes a bit more than we should. So if you're really in this idealized world where the data you have is perfect, the thing you're trying to optimize for really is the thing you're trying to optimize for, then it's true that if you want to additionally impose constraints like fairness or privacy, you're inevitably going to have to pay something in what you're optimizing for. But when you look at real case studies, we're not even close to this idealized world. So to use a recent example, there's a recent study showing racial bias in a United Health product that tried to target medical interventions at patients. And what it was trying to do is what it was supposed to be doing is it was supposed to be predicting health outcomes. But they didn't actually have data for health outcomes. Instead, what they used as a proxy was future medical costs.
Right.
And it ended up having sort of demonstrable bias against African Americans because sort of equally sick African Americans had lower healthcare costs, not because they had better outcomes, but because they had less access to healthcare. So this is an example where there's not necessarily a trade-off. You could simultaneously improve fairness and accuracy by simply improving the data, trying to optimize for the right thing instead of this incorrect proxy. So these trade-offs really only manifest themselves after you've solved sort of all of the other problems. Okay. And in many practical cases, you can simultaneously improve accuracy and fairness simply by getting better data.
Well, and that's why I asked the question, because I think in reading about the ethical algorithm, what intrigues me about it, it's sort of placing ethics on what's already imperfect, right? Because if you look at the case of criminalization of African Americans, it has little to do with how much contraband that they have. It just has to do with a system which disproportionately makes more arrests in Black communities, which allows them to be overrepresented in data sets. Or in the racial healthcare bias, it has to do with the fact that there's differential access or disparate access to health care, which made that feature ineffective for Black patients because we're not in the system. So I guess when you look at that and you look at this ethics framework for bringing some type of remedy to these imperfections, help me understand the correlation then between ethics and algorithm in your book, and how you actually see how everyday people sort of operationalize that.
Yeah, I mean, I think on these points, I mean, let me just point out that even in the example that Aaron gave, where like, look, you could really go do something that would improve, both the accuracy and the fairness of this predictive model. There's still costs involved, right? So the reason that this product in the first place used health costs as a proxy for outcomes was because that was expedient and they didn't have the data on outcomes. So to get that data, they would have to go do something that would cost them money. And we think they should do something like that, but we shouldn't pretend like, they just didn't realize that they had that data sitting on a different server and that it's just a matter of like pointing their model over there than over here. I also think that one of the things we try to be careful about in the book is that we are first and foremost scientists, right? We've learned a great deal in talking to people about these issues that aren't scientists, but we're quite careful to, sort of identify what science can do for us and what it can't do. Okay, so we're not here to propose, for instance, that algorithms pick definitions of fairness or privacy. We view that as firmly in the human domain, in the societal domain. And so we try to very quickly sort of say, like, look, we're not, imagining that an algorithm is going to kind of tinker around with the definition of fairness. We have to specify it, and that's a hard problem, right? In some ways, that's harder than the science that we talk about in the book. And there's also a lot of things that, even setting aside for precise definitions that you can explain to a computer, there are some things that are just like hard social problems, right? So if, your police are biased in who they decide to arrest or stop and frisk, if your criminal justice system is biased in the sentencing decisions that it makes or the bail decisions or parole decisions that it makes, there's no algorithm to fix that. We're still left with hard social problems of like retraining the way people view these issues and changing their behavior, right? And so, it's an interesting area to work in as a scientist because there's quite a bit to say about the algorithmic issues. But then there's this whole pipeline. I mean, there's sort of the world, then there's some process that collects data from the world that might have problems. That produces data. That data is fed to an algorithm. That algorithm produces a model. That model makes decisions that might then in turn affect the world. And we're kind of talking about the middle part of that pipeline for the most part. But some of the hardest problems are like on the other sides of it.
Yeah. So I just want to add to that. I mean, when we talk about these issues in fairness and machine learning, it's always a little bit in the abstract, mostly because people have only really just started studying this. Like these aren't widely deployed technologies, but you can get a sense for where these things might be in 20 years by looking at sort of the parallel field of data privacy, which is maybe 20 years ahead, and we talk about quite a bit in the book as well. So data privacy followed a similar scientific pattern where maybe 15 years ago, a particular concrete, like mathematical formalization of a kind of privacy called differential privacy was proposed, and for a decade, people like us wrote mathematical papers about it for other people like us. But it's recently become a real technology, and once that happens, these trade-offs become very real. So the census, right around here, is going to release all of the statistical products as part of the 2020 decennial census as subject to the protections of this thing called differential privacy. And there is a committee of people who are going to have to literally decide on a quantitative privacy parameter by sitting in a conference room and looking at plots about how privacy is going to trade off with the accuracy of the statistics. And there's no clear answer how to make this decision. I mean, privacy is very important. Census is required by law to protect privacy. But on the other hand, the statistics released by the census are incredibly valuable. They're used to distribute federal funds. They're used by demographers and other social scientists to study important questions. And in this case, now that the technology is developed and you can actually quantitatively plot out in your use case how privacy is going to trade off with accuracy, there are difficult decisions to be made. If you want more privacy, you're going to have to give social scientists and federal agencies less good data and vice versa. And I think that although we're only talking about these things in the abstract now, you can imagine that 20 years down the line, as some of these sort of fairness-supporting technologies are put into practice, real decisions about trade-offs are going to have to be made, the science is not going to have an answer as to how those decisions should be made. Of course, it'll be context dependent. What we can sort of most aspire to do is to make the trade-offs transparent so that stakeholders can make these decisions with their eyes open.
Right. So let me ask you about that. And this is how I actually met Michael when he gave a really great talk around inferences, though, right? And I want to kind of bring this into the conversation. Talking about data privacy, it probably was easier to talk about privacy when we were talking about rules of the road and privacy, you know, what particular things do I want protected, what can be anonymized, what can be de-anonymized. Now we're talking about this culmination of different micro factors that people know about us, right? And when you look at algorithms, much of the argument around, and I want to keep driving back at this ethics, right, of what happens with algorithms is that the data it's trained off of is not just me as a woman of color, but me as a woman who likes black boots, me as a woman who wears my hair in braids, that then makes assumptions about what I might purchase, what movie I might watch, where I might go on vacation, et cetera. So the question becomes, what do we do about that, right? Because there's not necessarily a framework, and that's, you know, in the ethics space of what is on limits and what's off limits when it comes to making certain eligibility determinations and other kinds of decisions.
Yeah, I mean, so I think this touches on both fairness and privacy, and just to make sure we're all on the same page, the kind of phenomenon that Nicole is talking about is, and there have been, you know, recent scientific papers on this, but the basic intuition is that these days we as individuals generate so much data that we might think of as innocuous and unrelated to who we are, that in fact acts as something similar to a fingerprint, right? So, you know, to make this concrete, you know, once you know that, let's say I'm an academic and that I use a Mac and that I drive a Subaru Forester and a couple other things, maybe you have a pretty good guess as to my political affiliation already, for example. And there have been very striking demonstrations of this. We discuss in the book a paper from now maybe 5 years ago that showed in a convincing fashion that just from your like behavior on Facebook, so nothing about, you know, who you are, your age, your gender, just from the content that you click the thumbs up button on Facebook, it's possible to some level of statistical accuracy, predict things like whether you are the child of divorced parents, your drug and alcohol use, your sexual orientation, and the like. So these things that you may think are just kind of digital exhaust, you know, you give me enough of that and it correlates strongly with who you are. And this has a couple of implications, both for privacy and fairness. So the implication for privacy, as we discuss in the book, is it basically means any definition of privacy that's based on notions of anonymization or removing so-called personally identifiable information, which unfortunately is by far and away the standard notion of privacy used in commercial practice to the extent that it's articulated at all. Those notions are all like fundamentally broken, right? And there have been many instances whereby, you know, even though they remove your name, your age, your social security number, all the things that we think of as personally identifying, you know, if I just know enough about your purchases on Amazon or your Facebook likes, I can pretty much reconstruct many, many other things about you. Yeah. And this is why, as Erin mentioned, this notion of differential privacy, which kind of eradicates these, you know, it basically is very different than notions of anonymization.
Right.
The implication for fairness, one implication for fairness of these kinds of correlations or inferences, as you were calling them, is that, again, you know, so in consumer lending, there are laws in the United States that forbid the use of race as an input to a lending model, okay? And the idea is that, oh, somehow by not allowing race to be a variable in the model, that you guarantee racial equality. So nothing could be further from the truth. And in fact, you know, in our book, we give a very concrete example of a simple setting where, in fact, by refusing to allow race as a variable in your model, you guarantee that you will harm the racial group that you were intending to protect by forbidding that, okay? And you know, and part of the problem is that if you try to restrict the inputs to a model, there are so many proxies for anything, right? I mean, unfortunately in the US, your zip code is already a rather accurate proxy for your race. So by, you know, notions of fairness that are predicated on forbidding certain inputs to the model are broken in the same way that notions of privacy that are based on anonymity are broken. And we advocate in the book that, like the fairness definitions we were given before, what you should really be doing is specifying what you want the behavior you want at the output of the model, rather than fooling yourself into thinking that you're getting some notion of fairness by controlling the inputs.
Mm-hmm.
Yeah, and this issue of all of these correlations out there in the world, I think there's really two distinct things that people might think of as privacy violations, and then differential privacy, I think, helps in disentangling these two.
And just for people who are not following the privacy debate, differential privacy, from what I understand, is when you put more noise in the model that do not allow a person to pick up your attributes. Is that right?
That's right, yes. Maybe it's helpful just to say briefly what differential privacy is. It's a particular formalization of privacy that corresponds to plausible deniability.
Right,
and it sort of takes the position that if I did some data analysis that didn't involve your data at all, then we shouldn't think of that as a privacy violation for you. And what differential privacy requires is that even if I do use your data, there should be no statistical test, nothing any outside observer can do that can let them distinguish better than random guessing whether we're in this idealized world where I didn't use your data at all and whether I did use your data. Okay, so this is a strong guarantee that I can't learn anything idiosyncratic to you from whatever is published, because I can't learn anything that I couldn't have learned even if your data wasn't in the data set at all. So the kind of thing that this can protect against, for example, just to use sort of a silly example, I don't know about you all, but the things I type into Google search when I'm, like alone in my room are embarrassing. I wouldn't want people to know what those are. And you might worry that Google's autocomplete feature, that suggests what should be completed when they start typing.
Are we going down that road, Aaron? We don't want to know what you're doing in your room.
would reveal what I'm typing.
Okay.
So differential privacy prevents against that kind of thing.
Right.
Now, there's this separate concern, right, that from the kinds of things that I make publicly available, for example, I've set my Facebook settings so that, people shouldn't be able to see things I think of as sensitive, maybe my political affiliation, my sexual orientation, but I allow them to see the things that I like because I think that's innocuous. I might also think of it as a privacy violation that people actually can correlate the things that I like and with these things that I thought of as my secrets and can guess accurately my political affiliation, for example. Differential privacy does not protect against that, and nothing could, because I have just the problem there is I have inadvertently revealed to the world by setting, my Facebook setting to public, all of these facts which happen to fingerprint these sensitive attributes about me. The problem was I didn't realize that these correlations were there. But preventing that is I think it requires education. Once people make that information public, there's nothing technical or even regulatory you can do to prevent these kinds of inferences from being made, because these are just facts about data that anyone can see in the world.
But I think and I want to talk a little bit about, we'll go to questions soon, what you're talking about in terms of just this fairness model. My colleague, I think he's out here, wrote a paper on lending, Aaron Klein, around people being able to determine if you're a good credit risk if you're using an Apple versus a PC, right? So there are certain things that people can get. I mean, the question is, yes, you can use those features, but again, going back, is it fair? And as developers, how do you get people to sort of weigh that? I mean, you're scientists, you're always in the lab creating these models that get deployed in different contexts that may or may not have, unforeseen consequences. So the question I have for you before I go into the policy part of this, what do we need to tell developers like yourself, to actually employ this framework that embodies fairness and ethics and, makes the determination that maybe this feature is not a good idea to use, or is thinking ahead that this proxy is going to create certain levels of bias?
Yeah, so first of all, I think the right party to be focusing this on is, sort of not developers in the traditional sense, but what we would now call data scientists or machine learning people at, let's say, large tech companies or lenders or the like. And, I think the good news is that, the prescription for what they should do different, for instance, to enforce fairness considerations is only minimally different in a scientific sense from what they're already doing.
Right.
So a lot of what these people do for a living is essentially solve optimization problems, the data-driven optimization problems. They have a historical data set of loans that were granted. Some of those loans were repaid, some of them defaulted. You know information about the applicant in each one of those cases, and you're using that historical data to say, like, find the neural network which does the best job on this historical data of predicting who would repay and who wouldn't, okay? Really, the only modification they need to make is to instead solve the, what we would call constrained optimization problem of find the neural network that minimizes the predictive error subject to the constraint that the false rejection rate on black people and white people not be greater than 1%, okay? And so, like, conceptually, these things are right next to each other. Now, that second problem is algorithmically more difficult, okay? And so you need to think about algorithm design to solve it. But it's, you know, it's in the same field. It's not like asking these people, okay, you need to go off and study for 5 years. You know, it's really completely within their wheelhouse to make these kinds of changes. And by the way, many of our colleagues in industry know this, and many of them, in fact, do the kinds of research that we're talking about in these areas. It's just a matter of those companies having the appetite to make those changes, because as per what we've said before, this will have real costs. If I'm Google and I want to make sure that in the ads that I show there is, you know, not racial bias, for instance, in who's shown lucrative ads for STEM jobs, enforcing that will mean lower accuracy overall in predicting click-through rates, and this is how Google makes money. So they will literally lose revenue by enforcing this, and they need to decide whether they want to do it or not.
So, I mean, but I want to stay on that for a minute, because I look at it like this: permissionless forgiveness or permissionless innovation has led to permissionless forgiveness, where we hear a lot of I'm sorries after something has been broken. And so I love what you're talking about in terms of getting people to realize that they have these tools in their toolkit. But the reality is, one tech company one company that is now a tech company is rushing to market quicker than the next company and the next company. And they often don't have the data necessary to actually make these kind of decisions. So do you stifle innovation, or do you still operate in permissionless forgiveness, or do you find something in between when it comes to the data science community?
Yes, so one of the things we talk about both in the book and this policy paper is that we do think that regulatory agencies have to become substantially more quantitative, because it's not always that the data is not there. You know, there was this recent sort of assertion that maybe the Apple Card was exhibiting gender bias, and we sat down with some of the New York regulatory people looking into this, and what they said is that you know, at many of these sort of lending institutions, in principle, they have the data to check, for example, whether their system is systematically giving lower credit limits to women versus men, but they don't want to look into it because this would open this fact up to discovery if there were a lawsuit. And right now, there's sort of lots of uncertainty about what regulation actually requires them to do at a quantitative level. And so I think that, you know, in some sense, like, there's clear things they could do, and they're, because of ambiguity in the regulatory environment right now, they're reluctant to do it. I think that if we are going to start trying to productively regulate algorithms, which are rapidly making decisions that we can quantify, we should be precise about what regulation requires them to do, and we should think about how to audit them.
Right. So I want to go on the regulation side. In a few minutes, I'll answer questions. So I'm going to give you a little secret. There aren't a lot of quantitative people in government. That's not a space that people decide to go to government because there are agencies that have quantitative researchers, but just nearly not enough to keep up with this innovation economy. So then what do we do? Like, how do we begin to employ regulatory frameworks that make sense, given, I think, some of the concerns that we've talked about so far?
Yeah, I mean, so I think this is one of these things that falls into that category of hard problems with no easy scientific fix.
Right.
You know, we understand the science, as Aaron said, and I think, you know, as we argue in the Brookings brief, that that the kind of thing that we're proposing, while scientifically possible, is going to require real change at the regulatory agencies, whether it's the current regulatory agencies or new regulatory agencies that would be created, and the composition of the personnel at these agencies will need to look very different. You know, you know, the gap, you know, the gap between technology regulators and the companies that they're regulating has grown, I think, dramatically in the last 20 years with the advent of the consumer internet and the rise of AI and machine learning in these companies. And I think it's not a level playing field. And so until we find ways to get more people that think like the companies that they regulate do in the agencies and know that have the same skill set, I think it's going to be very, very difficult. Another thing we discuss in the brief, you know, that's less about, let's say, fairness per se, but things about, you know, competition law. So in my experience, you know, in regulatory cases involving technology competition law, I've noticed that, you know, regulators are forced by law to view things through a lens that's entirely at odds with the companies they're regulating. So, you know, if some tech company is thinking about acquiring a startup in some particular, you know, sub area of tech, the first thing they have to do is identify the market for that particular piece of technology, and then decide whether it's nascent or mature, and who the competitors are, and whether the acquiring company is kind of an incumbent, or whether the playing field is sufficiently level. And you know, you talk to people at tech companies, and they just don't see the world this way. They think, like, when Google thinks about acquiring a company, they're not thinking like, oh, I'm like getting into this new narrow segment of technology. They're like, wow, if we had that data,
Right.
we could combine it with our data from Gmail, from search, from advertising, from Waze and Google Maps. And they don't think about it in this compartmentalized way. They think of the whole thing as a single piece, kind of, you know, bundled together by the data that they're gathering. And when you force regulators to look at the world that way, it fundamentally handicaps them in sort of, you know, doing sort of, you know, things that have teeth in their domain.
Mm-hmm.
Yeah, I don't have too much to add to that, and I'd say, you know, what we as scientists think the state of the world is right now is that, you know, we're at the place where in principle, in an ideal world, there are sort of concrete things you could do to audit and regulate algorithms for, you know, desiderata like privacy and fairness. But we have no particular expertise into how to get to, you know, a state of the world in which there are regulatory agencies that are actually prepared to do this, and how difficult it would be. And I think that what's needed is a, you know, long-term collaboration between legal scholars, regulators, and technical folks, computer scientists, and hopefully conversations like this are the beginning of that. But you know, I don't think we have a silver bullet in mind for how to get from A to B.
Yeah, I mean, I want to just add to that. I love, and again, their paper is available online at the AI Bias website link, if you bring that down. I mean, I think to your question of, you know, should we have more quant scholars at regulatory agencies? Of course, right? But I also think we also create another disadvantage or barrier, particularly when we look at diversity, right? How many people of color are actually getting STEM degrees to be able to compete for those jobs? So then you have something that is now a tool that is widely distributed that affects everyday people, with people who are either regulating or designing them that don't look like the people that are the subjects. And so I think the whole thing is what Michael said. It's a big, complicated mess that we need to really think carefully around. How do you mix the design, the regulation, and the other civil society aspects to create, particularly in the use cases that matter, right? Algorithms that are ethical and are fair and have some level of precision that can be explained. Yeah. Right, in the end. So I don't know if you guys want to make a couple final comments. I'm going to open it up to questions in just a moment, but any comments on that?
Happy to take questions, I think. Yeah.
Okay, perfect. All right, so we're going to go to questions. We have microphone coming down the middle, and state your name and keep your question brief and not necessarily commentary, so I get as many as possible because I have 15 minutes.
Yes, absolutely. Thank you guys so much for being here today. Number one, this was very enlightening. Number two, I would like to introduce myself. So my name is Keisha Ash. I'm a former AAAS fellow at the National Science Foundation within the Computer and Information Science and Engineering Directorate, Education Workforce Development.
That's a long title.
That was my former job. Right now, I'm a free agent. I actually just launched my 5th company today called treewaterconsulting.com.
So I know you just want just
And
turn
so,
it-
no, I do. So I actually have an answer, a question, and then an answer, okay? And so the answer to your question is you must encourage your industrial friends to employ more people who are women, people of color, people with perceived disabilities, all of those things, okay? We need to diversify the tech workforce,
Agreed.
okay? You all are leaders. We need your leadership, okay? So that's the answer.
And
The,
Keisha,
the question,
we have a paper on that coming out too, so you'll see that.
excellent, excellent. The question is, what are you going to do? The answer is, I would strongly recommend contacting Barbara Whye, W-H-Y-E, at Intel. She has developed an entire system with her engineering degree. I'm an engineer, by the way, and I'm getting my computer science PhD very soon. Barbara Whye. Look her up.
W-H-Y-E. Okay.
W-H-Y-E.
Thank you.
Alton Coleman, James Madison University, Ethics.
All right.
Okay.
Thank you, Keisha. I appreciate that. Thank you. All right, next question. This lady in the red.
Hi, Nicole. It's Judith Hellestein. My
yeah.
question for you is, we have so much of the, in the algorithms, there's so much also bad data that individuals cannot correct. In many of these, they say up to 30% of the data is not correctable. I would like to see a movement of how individuals can get their data and correct their data. Because as you said, one of the problems with the algorithms is the racial is a bias. But what about the inherent incorrect information in there that is creating more bad information, as they say, more bad information in, better information out. And how do we go about correcting that data?
Right. So I'm going to bring that question over to you two and just sort of think about it before we answer that. What Aaron does in his room is what he does in his room. That's accurate data for any of us. But how do consumers correct what they think are not what's accurate about them?
Yeah, so that's a good question, and just to sort of elaborate on it, it's true that right now, like if you go and you apply for a credit card or a credit line increase, you're going to get a decision, maybe in less than a minute, but you don't have any transparency into what data was pulled in about you to make that decision, whether it was just your credit score or whether it was using social media data or the correctness, and that's a problem when there are data errors. So what I would like to see is standards by which you would have the right, as you do at the moment with credit reporting agencies, to have transparency into the data that is being fed into these algorithms so that you could take a proactive stance to correct it when there are errors.
Right. Do you think that's a legislative action in terms of explainability of algorithmic decisions? Because you just triggered me, much like credit reporting decisions.
Yeah, so first of all, I mean, I agree with Aaron on kind of what the nature of the solution needs to be. Unfortunately, this is one of these things that's sort of not, it's not a technical thing. It's a legal and policy thing. It's requiring companies to provide certain mechanisms by which you can see what they've got on you, and you can change it. And one obvious thing that I would point out is that we live in an era where the efficiencies of algorithmic decision making are such that that allowing that kind of deliberative access and revision is at odds with the efficiency that have been gained by technology. So there are going to be some hard frictions there. Yeah. On the topic of transparency and interpretability and explainability, these are also things that we talk about a little bit in the book towards the end. The reason we don't talk about them a lot is that we think that in relative terms, the sort of scientific maturity of research in those fields is very, very nascent. So in particular, even though there might be multiple competing reasonable definitions of things like algorithmic fairness, we don't think there's even a single good technical definition of what it means for a predictive model, for instance, to be interpretable. And part of the reason for that is that if you think about the word interpretability, it implies an observer, right? It's sort of interpretable to whom? And do we mean interpretable to people who work in data science? We probably mean something broader. Do we mean interpretable to people who sort of have a very low level of numeracy? And then that would be a different notion of interpretability. And so we think that the research that's needed here is almost more behavioral. And that tends to not happen in areas like computer science, although there have been a couple of nice recent pieces of work.
Yeah, no, I'm just on that. I think that this is really great because I think as a policymaker, goes back to people being able to audit algorithmic eligibility determinations, perhaps, that could have some feet to it. So thanks for bringing that up. It's something we look at. Over here, I got a question.
Hi, everyone. Hi, I'm Vikram Surya-Chirvalu. I'm a computer scientist and a psychotherapist.
Wow.
Not too many of me. Thank you, Nicole, for pulling this together.
That is very dangerous.
I'm also the CEO of an organization here in D.C. called technotherapy.org.
Wow, so I'm just going to not say anything else.
Found your niche.
Right?
It's been an interesting course of life that got me to this point. I just had to be here today for this conversation. One thing I want to put in the room is I worked as a computer scientist in industry for many years. I never had to sign anything that had anything to do with ethics. There's no expectation. When I became a psychotherapist and I became a licensed clinician, I was subject to ethical codes of the American Counseling Association. My professional identity that way is a counselor. And so one sort of question I have is there any way we're going to get out of this if we have a workforce that isn't actually themselves like committed to ethical practice in their work? And I think a place to think about that is obviously computer science and electrical engineering. My second question is to do with the business side of this, but I think that's the first question I'd ask.
Should computer scientists be taught ethics?
So I think, that's a good idea, but I think that having people sign a piece of paper is not going to solve the problem. And part of the reason is because I think it's very hard to anticipate the effects that, if say you're a software engineer and you're, pushing some small update to the Facebook news feed, for example, it might be entirely non-obvious what effects that's going to have. And, lots of the things we think about as possibly problematic in social media, like the creation of filter bubbles, leading to maybe a less deliberative society. I think that those effects were not very easily predictable at all at the moment that updates to the Facebook news feed that ultimately led to these effects were deployed. And so I don't think that the problem is so much that we have unethical software engineers, although there's some of that.
Let me just interject here that I think you're exactly right. There's the law of unintended consequences. You build something, you have no idea how it's going to sort of go into the wild, right? But as soon as we know, for example, that we have this scenario with automated discrimination with mortgages, right? I, as a computer scientist at that company, if I don't have any ethical obligation to pay any attention to that fact, I can go on doing what I'm doing. As a psychotherapist, I'm subject to licensing boards. I'm subject to things that have, as you say, teeth. Like, I won't be able to make my living if I continue to ignore something that's a clear ethical result that's out there.
So I don't think it could be a bad thing to have people sign such a piece of paper. But I think in our view, the areas where there are problems for which we think there are scientific solutions, as we said at the beginning, the problem is not amongst rank and file scientists and engineers who are inflicting their biases in the models that they build. These are corporate problems, right? So I think where the pressure is needed is not from the bottom up, but from the top down. It's to really make tech companies, for instance, or lending agencies have a policy or a law or regulation binding them to audit for things like gender or racial bias in their predictive models and eradicating it. And that requires, as we've said, like the regulators getting precise about what they mean and what the requirements are so that the companies don't have an incentive not to look at things that they don't want to see, okay? So you have to force them to look at it and see it and report on it and let it be audited. And so while I agree, yes, I do think engineers should be taught ethics. In fact, I teach a course at Penn on exactly these topics. And by the way, it's mainly a technical course. It's sort of how do you implement machine learning in a way that avoids fairness violations, for example. It's not.
Is it required?
Huh?
Is it required?
Not yet.
Not yet, not across a lot of
They're thinking about making a requirement. I mean, that also limits the audience because then people from arts and sciences are more reluctant to come over and take some required engineering class. It's complicated academic dynamics. But I think people need to be exposed to this. But I think where the real action is in the near term is not that we kind of need to train better people in the abstract, is there are concrete things we need to make companies do.
Right. Well,
And so how, my question there is how, and
okay,
forgive
now
me.
you
I don't
got
mean
that
to-
mic for a
I
long
know.
time. You're almost done.
I'm going to let it go. I'm going to let it go.
I'm trying not to have you analyze me in any respect in terms of your background, but you have been holding that mic for a minute.
Give it back.
Do you have one quick 30-second wrap-up because we're running out of time?
Well, so just to your point about that, I've worked in a corporation where, we knew that there was an ethical issue, right? But just exactly as you described, we knew competitors didn't care about it either. And my job as a computer scientist in a company is to do what the investors say needs to be done. And so how do we actually, because I think at a regulatory level here in DC, knowing exactly to your point, they're not techies. Like, we're not going to get into the weeds of these algorithms. Like, does there need to be something with significantly more teeth? Like, one concept, this is something that Elizabeth Warren has floated, is making every corporation a social benefit corporation by default, so that a person who works for the corporation isn't in breach of fiduciary duty to make a socially beneficial decision.
Right. Well, I want to add to what you said, though. I think the questions that you're bringing up are really critical, particularly as the technology has evolved into this space where we have so much more data about people. And it's actually not just going to be a corporate effort, but it's also going to be the effort of individuals to understand what's happening to them as well. And so I think going forward, you're going to need that consumer education. The same way we moved from an HTTP to an understanding that you don't put your credit card there, you put it in an HTTPS. All of these variables are going to have, yeah, right, exactly. I mean, not being shameless about this at all. At Brookings, we're working on an algorithmic rating system that actually incorporates a lot of what you're talking about. And I do believe that ethics at the undergraduate and graduate level matters. But I do want to add one more thing because I can hold the mic and say goodbye to everybody at the same time. Unconscious bias is still real. So you can teach ethics, and people do come with their values and assumptions, but they also come with their assumptions and values of the world are influenced by who they are. Whether you come from the north, the south, the east, the west, you're woman, you're a man, you're short, you're tall, it all factors in there. And that's all very important as we move forward. It's a debate that none of us start with a blank slate. So with that, he is the reason that we run out of time for another question. With that, I want to say, let's give a round of applause to Michael and Aaron. We want to, again, thank you all for coming out to participate in another event series on our AI work here at Brookings. Follow our paper series. And on your seats are evaluations. We want to improve the quality of the events that we give to you here at Brookings. And be sure to give us some comments so we could do better the next time. Thank you very much, and buy their book.
Thanks for watching. Be sure to like and subscribe for more videos from Brookings.